So our next two presentations, actually, they are coming from Marvell. I'm happy to introduce you to the next speaker. Is Alireza Razavi. He's currently a member of the digital signal processing team at Marvell and is defining and developing various Ethernet solutions, not particular for automotive, but also for other markets. He has more than 12 years of experience in high-speed Ethernet PHYs and received his master and PhD from the University of Minnesota. And also he's contributing to the standardization. He is active in .3 in the standardization. I'm really happy to have him here. Alireza, the floor is yours.
Thanks. Is the mic working? Yes, sir. Okay, perfect. Let me move my cable up here. So, this is the one, right? This is moving. Yeah. So let me start to tell you what I'm going to tell you. So the whole things I'm going to tell you here that we have in the zonal mindset network, we have a shorter length cable compared to what we have in the point-to-point connection. And because of that, it means that we have some margin. And we can use this margin to make the system more robust, less costly. And that's the whole thing we want to do. We want to talk about this, bring it to the people here. So you have seen this picture before, all of you, is talking about domain-based versus the zonal-based. But I want you to pay attention to one part, that here we are, from this processor to this node. We have the long cable that connecting these two guys together. So this cable that we have here in the domain base, which is a point-to-point connection, gonna be replaced in zonal base to the much shorter one, this one here. This is a small one here. So if we wanna look at this in the point-to-point connection, we are talking about longer cable, 15-meter cable. Depending on the speed, sometimes 11-meter cable. What we want to do, and we have multiple inline connector, maybe 4. Interzonal one, sorry. Maybe I go too much farther, that's me. Interzonal one, we have much shorter cable. I heard 2 meter, I heard 3 meter, I heard 5 meter. And I heard 8 meter from some people here yesterday. But essentially, it's a shorter cable with the less number of connector, inline connector. So we want to see how, if we use this, how it's going to help us. And going farther, last week when there's a meeting about a study group about the camera bridge, people talking about eventually camera going to connect to one of these bridges, and the link's going to be lower. I heard the number of 5 meter there. So this is all things coming that if you think zonal versus the point-to-point connection, we will have some margin that we can save. And talking about margin that we can save, this is a system that we want to use and save a cost in it. And system has some link partner sitting the other side. We have the cable there, and we have the PHY sitting in the system. We have the coder, make the digital signal to analog, send it over the link to other side, get the signal from other side, make it digital, cancel it, equalize it, get the signal out. And we have some form of echo canceller in between because we are transmitting in the both directions. So now, when we want to save, we want to optimize it, we are talking about usual suspect. We are talking about power, we are talking about area. And I want you guys to remember that when we are talking about power, it means we need to less operation. When we are talking about area, it means that we need less logic and we reduce the size. So this is going to be less operation, less work to do, less point of failure, less complexity. So that's also another benefit we want to get. And I wanted to start from this page, showing you what's the difference between short cable and long cable. And I found that easier to do with the cable, you know. This is a cable we have. I got it from our lab. It's a 15-meter cable, and I put it here. You can see this is a 15-meter cable we have. It's coming up to this point. And if we replace that cable with this what I got in the lab was 4-meter cable. We want to have much shorter link. And that's the image I want you guys to have. That's 15-meter cable. If you replace it with this small cable, how much benefit we're going to get, and where we're going to get the benefit. So this is all. And let's start from the usual suspect. The first one is insertion loss, right? So if you have a 5-meter cable with that much of insertion loss, the blue line in the top, what you're going to get as an eye, you're going to get open eye. When you send -1 and 1, you have open eye by itself. So easy to detect 1 and -1 here. Look at the other picture, 15-meter cable. 1, -1 is there, but it's hard to see. It means that we have to put equalizer. We have to do something to get the good picture like this. So that's the cost. And we go farther. This is one aspect. When we look at the echo canceller, same graph. So 5-meter with this much of insertion loss, with replacing 50-meter with this much of insertion loss. Now, we are having the echo that's this much, this black line here. Now you can see, if you can want to figure out what is the other side telling you in the presence of echo, it's much easier to work with a 5-meter cable. You have to do less job to push this guy down enough to get a good signal. But compared with 15-meter cable, this cable here, we have to do significant job in echo canceller to reduce this magnitude. And even more, in the echo canceller, we can see more benefits. So in the 5-meter, the signal has to go, where's my 5-meter? Signal has to go from one side to another side. Come back to me, I have to cancel. That's the longest echo that I have to cancel. For this cable, the signal goes that direction, come back here, and I have to cancel this echo. So it means my echo canceller should be bigger, should compensate for this echo signal. So now what we're going to do with this? So we have some benefit going with the shorter cable, right? In the zonal, we can have this shorter cable. Which kind of benefit we can get? So first, we can do nothing. We can do nothing and have good margin, you know? There's a shorter cable, we have a better margin, perfect. Another one we can, but you know, margin means you have to pay, right? There's a price to have a margin. What we can do, we can use less expensive cable, we can use the power, we can try to reduce the power and area. I'm going to talk about this in this picture. So the first one is about using a cheaper cable. So here, you don't need to change anything. You're going to use the same phi, the link pattern is going to be the same, but telling the cable company or cable vendor that, remember that 5-meter that you gave me before? I can do it with the worst cable. If that cable have an insertion loss similar to 15-meter, I'm okay. I can handle it. Give them some freedom to do, and hopefully they come with a cheaper solution. I have seen some people in the exhibition for optical, they are using this trick. They are using the older generation cable, and they are essentially reducing the cost of the cable. In this one, I hope that gets some input, some answer that this can be done in copper side. The other things we can do, we can save power. So we can add some hardware in our system, say, oh, if you have a shorter cable, let's have a mode, and when I detect I'm dealing with a shorter cable, I can reduce my requirement for my echo canceller. I can use the easier equalizer. I can relax some setting in ADC, my analog to digital converter, analog front end. So essentially, reducing power, putting some complexity there to get the benefit. But this method, although it's good for getting the power, is not a good method to get you saving in area, in the cost. Because the same phi has to support 15-meter cable. So this is the things you have to build for 15-meter cable. It has to support this. So you have, in the hardware, you need this much of equalizer, this much of echo cancel. All of this is there. You can turn it off, but add in some complexity. But it is there. So what else we can do? So think about it. So if we have to change something to get the full benefit of the system, this shorter cable, what else we can do? Can we should we stop there and say, hey, we're going to get the saving we can get with the system we have? Or can we do more? And one of the things, as an example I brought, that we can use it to get a better saving is changing the baud rate. And I will tell you, this one going to tell you why the baud rate is important in the system design. So in the multi-gig device that we have right now, 10 gig, the symbol that getting to you, the rate of is 5.6 gigahertz. So it means data is coming to you in that rate. You have to address it, you have to filter it, you have to multiply it, you have to create a delay, you have to add it to something. All of this operation, when you are talking about digital side, it cannot be done with that rate. So the hardware, based on the process that you're using, has some limitation about the maximum speed that can do effective multiplication or effective addition, right? So what people do is say, hey, my hardware in this process has limitation of the 1 gig operation. So the way we're going to do it, we're going to do 5 or 6 of the 1 gig in parallel of each other, right? Each one handling 1 gig data. But together, they're going to handle 5.6, we're going to be fine. But guess what? What we have here, we have hardware sitting parallel to each other. You reduce the baud rate, you don't need this parallel path. So area, very fast, going to reduce, right? And you're not need to power that area that you're not using anymore. So you're going to get the power saving tool. And by the way, this was kind of trick that people use before when we are moving from the higher node to the lower node. When they are moving that direction, some of the savings coming that, yes, the node was smaller, but then the newer node was able to do the operation faster, so they get rid of this parallel path to make things faster and cheaper. So the first question is, okay, so yes, this is going to have saving, but do we have a margin? Do we have a capacity of doing it? And for that, we are using the tool that is introduced in the standard, in 802.3CY. There's a tool that says, if you have this type of cable with this much of echo, how much margin we have in the end? Is it good? Can we do it this way or not? And it's a big table. You can find the tool in the website of the standard. But essentially what we did was say, let's assume that we are moving from PAM4 4-level signal to 16-level signal, PAM16. So the speed, baud rate going to be divided by half. But each symbol, instead of sending 2 bits, you have to send 4 bits, right? See if we can do it. This is possible. And say, so 15-meter cable we had before. We change it to 5-meter. The PAM level from PAM4, we make it PAM16, right? And this is the critical number. So margin we had here, about 4.5 is positive, is doable. And for that cable, 5-meter cable, the margin is positive. It's still positive. It's not that big, it's 2.5, but we still can do it. This is possible to do. But I want to say that I'm not suggesting here that let's go use PAM16. It's just say, this is the one thing we have to consider. There is other problem has to be solved to see if there's a good solution or not. We have to talk about EMC. We have to talk about error correction code. We have to talk about delay in the system. We have to talk about jitter sensitivity. And this one, it is need works. For example, for EMC one, you can say, okay, I have a 4-level signal. I replace it with 16-level signal, right? So distance between 2 levels is going to be smaller. So same amount of noise, then I have more problem, that this is going to cause problem for me. But one thing is happening is that when you are doing this, when you are going with high dimension, in the same time, you reduce the insertion loss in the cable, right? So the gain that you have to do in the receiver is much lower. You don't need to magnify the signal a lot, as much as you did in the other one. So when you're not magnifying the signal from the other side, you're not magnifying the EMC that get to you. So that's going to benefit. But again, this is something that we have to look at the number. This is conceptual-wise. We can argue about it, but it's better if we do a number and look at the number. So at the end, this is the whole thing. I want you guys to remember that in the zonal, we had the opportunity to look at the cable and say we had a much shorter cable versus that 15-meter cable. This means we have a place that we can optimize. We can make the system simpler. We can get rid of complexity. We can reduce the number of failure, perhaps, or reducing size, reducing complexity. And that's it. And it's up to us to define this, to figure out what is the best way to do, what is going to give more benefit. And that's all.
Thank you very much. Are there some questions? Yes, Steve. Hurry up. You want coffee?
Okay. So first of all, thanks so much for this. The other thing, for those of you in the audience, we worked together for 3 years on CY, and we just met today because it was all done on Zoom during the pandemic. Yeah. So this has been kind of cool. Can you flip to the page where you use Ragnar's spreadsheet?
Sure.
Yeah, right there. So I just want to make it clear, this is not actually part of the standard. It was used to help us come to the decisions. I believe it was primarily done by Ragnar Jonsson, who was his colleague. I'm sure you had input too. But this tool was beautiful. It's an Excel spreadsheet. It is out on the CY website, and you could download it and use it yourself. But it is brilliant for letting you do these really quick what-if trade-offs in this kind of thing. So anyway, thank you for bringing this in.
Sure.
Thank you. Further questions? Ricardo.
So Ricardo from Robert Bosch. Just a question. I see you make the comment that we can short the cables with the Zonal architecture. Now the question is, how much can you really short the cables? Because at the end of the day, the cable harness, you have to connect sensors. And if you short, you don't reach the computer. So.
This is a very, very good point, right? And frankly, at this one, I heard too many numbers. I go to the history, 2021, I think, I see the presentation talking about 3 meters. Then in the study for the camera bridge, that I see the number 5 meters show up, that people say 5 meters. I was talking with Michael, I think, yesterday, and he's telling me, no, sometimes we have to go 8 meters. So, but this is something that we can work together and figure out, right? The point that you are making, and also I talked to Push and see how you're defining the system, is about how much we can save there, right? Some of the things, and maybe it's coming from we have a mindset of the point-to-point and how we have to deal with it. Sometimes, maybe if we go to the zonal way of thinking, maybe we can find a way to make a cable shorter. And again, how much shorter, right, is a key question, right? That's the point that we have to solve and see what's really achievable. And that's the reason I'm coming to all of booths and asking people that, hey, what's the limitation? Why we cannot, why 3 meters, why 5 meters, why 8 meters? And I want to learn, and it's good that we have to have discussion with all of us and figure out what is the right length going to be. And does it make sense or not? Maybe it doesn't, right? But that discussion should happen because we are in that point.
Philip?
Yeah. So this is Philip from Exxon. So 2 questions. First, this sounds a bit as if you were proposing some sort of like profiles or something, so that the industry is at least considering to have, let's say, hypothetically a 10 gig PHY or 25 gig PHY for the long cable scenario, which would be more power hungry, more expensive, and a second one, which is specifically then tailored towards a different profile kind of thing. So my first question is, why not letting Moore's law somewhat solve the thing itself? Eventually things like shrink and power is reduced, and the question is it worthwhile going through the effort of like doing it twice? And second, resources are scarce, especially R&D. Does it make sense to waste R&D resources doing 2 things which is in essence do the same thing?
So I answered your second question because it's very easy to answer, right? It depends on which kind of hat you have, right? I have an engineering hat. In my engineering hat, I say, yes, we can save, right? But the question that comes to the marketing, does it make sense? Does it not make sense? That's become beyond me. The only thing I can tell people here that we have this opportunity, right? Let's think about this opportunity. Maybe 5-minute talk, we say, okay, that opportunity is not realistic. Maybe it's not realistic. That's a good question. That should be answered. My hat is different here because I'm an engineer. So I say, okay, I have this tool. Guys, are we able to use it? That's the only thing I'm bringing, right? That's the first. Second question. And first question you were asking, I guess, was about, sorry, I forgot your first question.
So essentially the question was more going towards why not over-engineered and then eventually let's scale it down to go eventually to 3 nanometers and so on, and then
the
stuff
things
gets just cheaper anyways.
Over-engineering one, because all of you guys are going to pay for it. So when we over-engineer, we are putting more hardware, more logic to do the job that is not needed, right? And so when we are driving our car tomorrow, that price is there. Again, I'm not trying to answer marketing or sales and other part or resource. This is not my thing. I don't know anything about it. The only thing I know that if we put this PHY there, right, that's designed for 15-meter cable. And most of the cable, and there's a 1 cable there, 1-meter cable, right? That 1-meter cable is wasting some resources. And maybe introducing some complexity, because you have to say, okay, I want to bring the power down. I have to add some complexity in the system. So you have to test it in the different corners, short cable, long cable, to do much more stuff to make sure that 1 meter is as safe as 15-meter that was initial thought. You also asked you mentioned, what is the best way to do it, right? Is it make sense to have separate standard, or say we have a different profile? First, this is done before, it's some of the standard we have for industry, we had a much longer length, we have shorter length for the automobile. So this is done, but I'm not sure. I have no idea what's the best way. And I'm hoping that together we find out, okay, does it make sense or no?
Another very quick remark is that this over-dimensioning or over-provisioning is something which is already done in the industry also with other features, like, for instance, MACsec, or if you just purchase a traditional standard PHY, it comes with all the XMRI flavors, and in reality it's only like 1 used. So a devil's advocate kind of question you don't need to answer is, why specifically now tailoring or optimizing this problem when there are other things which could be optimized as well, essentially?
So, excellent question again. I mean, the question, we see a lot of talk. Before my talk was another talk, right? And he was mentioning different type of problem we have to solve, right? So figuring out which topic is worth it, that's also good, something that we have to think. That is it worth it here or not? This talk, my background is PMA, that cable, DSP, these things. And I'm talking about that part. And that part I know, the part you mentioned about MACsec or other things, I don't know that much. But up to this point that I have to give you the bit that you can trust your MACsec, that point, and say, hey, there's some saving we can do if we are using shorter cable. Make sense or not?
Yeah. Thank you.
Yes.
So, Yannick.
Yeah, thank you for the presentation. Sure. You were talking about cable lengths before, and yeah, I think I remind of the .cy standard. There's also an insertion-loss budget. Like you have this and that number of budget for the link. So you're always talking about the length of the cable, but the cable itself has to also get some electrical characteristics and stuff, and therefore there's also a insertion-loss budget in the standard.
Sure.
So let me rephrase the question. Do you think there's any better solution than with the budget or with the link length? And do you think with the budget it is easy to understand for people when they read the standard, or is it easier that you just go with the length?
So this is the good topic. I think the 15 meter in the standard, Mr. Carlson here, he knows much better, but I think I saw it in one place that was a 15 meter, some place it said up to 15 meters somewhere, and we had the other part that...
At least.
Yeah, yes, yes. And there is other part that talks about electrical spec, insertion loss, return loss, right? And this is a good question. So what is the best way to do? I really don't know. So, right? So we had this spec, right? It's talking about insertion loss echo. The question here is that I don't know, can we get cheaper cable, 5 meter, that satisfies that setting, right? So the overall cost of the system going to be optimized by just changing the cable. I don't know the answer of that. I have seen that people, yesterday I saw it in the exhibition, that people doing it for optical side. And they say, oh, we're going to use this connector because of has it's cheaper and blah, blah, it's good. And I've seen that things happen. I have no idea. I'm hoping somebody here and just raise this hand, oh, no, this can be done or this not can be done. So I'm hoping to get this input also from you guys here. I don't know.
So, Steve?
Sure. No, all I was going to say is that for all the automotive PHY projects, we had to define the link segment. The data center guys don't. They're working with cable groups around the world to do that, but we had to do it ourselves. And one of the inputs that we got from the auto industry is, okay, what kind of reach do you need? What length do you need? Make it as short as you can, okay? So 15 became the one, at least 15 became the mantra in 1000 base T1, 2.5, 5, and 10. When we got to CY at 25, we said that's just not going to work. So it got back down to 11, which is a compromise of how short they thought we could live with how far we thought we could actually build a part. For example, if we had been able to back that down to 8, the CY-Fi would actually be substantially simpler than it is right now, and the link segment would have been simpler. So everything's a trade-off. And that 11, it's not a magic number. It was negotiation, trying to see what everybody could live with. And I agree with you. We get to 5, life would be golden, but we're not there yet.
Yeah, and the question is that it's going to be 5, it's going to be 8, it's going to be 3. Can we together do something to put the limit? Is it worth it after that? It's all this open question. You know, if you have a 15 cable, it's going to be tangled up with your speaker, so that's still going to happen. With 4 meter, no, it's fine. So.
All right, further questions? Colt, last one. I need coffee.
I'm not sure I quite understood the premise of the whole presentation. You're saying the cables within a zone for point-to-point link are going to be shorter. That's obvious. Yeah. But in the zonal architectures that I've seen, I don't see very many, if any at all, point-to-point Ethernet networks. They're just going between the point-to-point Ethernet on the zonal architectures that I've seen are just going between the between the zones and to the central compute module.
Okay.
So if a zonal controller doesn't have point-to-point, it's a moot point then. It's not going to save any cost because I've only seen 10 base T1S, CAN, LIN, and other networks within a single zone. And the only point-to-point. So I guess if the OEMs or suppliers can correct me on that, but I'm just curious if that's a common use case.
Cold, very simple. Yes, there are other use cases of point-to-point. We saw 100 megabit, we saw a gigabit, and also we saw 2.5 already. To the zone and from the zone. Currently is based on .3ch. I think 5 is the maximum that I saw so far. It's all there.
I don't know, it's related to your question. I didn't pick your question very well. But, Bosch has the camera 10 gig connected in their Bosch system. And I don't know the cable length they're using there. Is it that's for demo, but I don't know in the real application how short they're going to use.
Correct. So further questions? Seeing none. Then we'll break the last time for the coffee break. And please, this is also the last time that you have the chance to see the exhibition in the booth area. So make sure after 3:30, no, 3:30, yes, the exhibition will be closed. So take your chance. See you.